right, everyone. Let's look at exercise 4.1. It's extremely easy and much easier than anything we've done in chapter 3. So I'm just gonna sort of cherry pick a few of the problems here, and then if you have other questions, of course, I'm available to you in the class. So let's go to number 2b. State the coefficients of x and y in each of the following expressions. The expression here is x squared minus x plus y minus y squared. So a coefficient is obviously a number that's attached to a variable. We don't see a number attached to these variables, so we can probably guess that the coefficient that they had in mind is number 1, right? 1 times x squared will still equal x squared. So we simply just omitted writing the number 1 next to these variables. Okay? All right. Let's go to 3b just to do it, right? So 5b minus 8b. So we get like terms, so we can just perform our normal operations. So 5b minus 8b will simply equal negative, goodness gracious, negative 3b, right? Okay, how about 3e? 3e has p plus p plus p. So how can we simplify this expression? Right, it's simply 3 times p, isn't it? It's literally p 3 times. 3 times p. F, 3f. Q plus 2q minus 10q. Q plus 2q will equal 3q minus 10q equals, we have equal terms, so simple arithmetic, right? Negative 7q. I hope this is starting to become more comfortable for you guys. There's really nothing much to it when we're dealing with like terms. Okay, on the next page, page 97, let's look at example 4e. I was trying to find something that would look remotely complicated, but they're really just, I mean, I'm not going to say they're not complicated because maybe it's just simple for me because I've done this before. All right. I'm writing out the problem here, and they're being, no, why did I say that? Yes, I'm correct. They're being very tricky by using P's and Q's. So at first sight, they all look like the same variables there. So I will be careful with that. So what I say in these kinds of problems, guys, just combine like terms. Okay, here's that. So we've got 2/3 p plus 1/6 p. Then we've got negative quarter q and another negative half q, right? And here you're going to have to bring all the like terms to common denominators and solve as usual. So in this portion here, the common denominator can easily be 6, right? So we're gonna multiply by 2 here. So 4/6 p plus 1/6 p equals 5/6 p. Okay, now let's go to the q portion of our problem here, of our expression, and we've got negative quarter q minus half q, so we can easily make 4 a common denominator. So we've got negative quarter q minus 2/4 q, which will equal negative 3/4, 3/4 q. And there's your answer. This is your answer. 5/6 p minus 3/4 q. And there's absolutely nothing else that you can do in this expression here. All right, it seems I'm out of canvas, so I'll be back.